Section 6.3, Example 2 says, in the stained glass window design, the side of each small square is 5 inches. Find the perimeter of the window to the nearest tenth of an inch. So I have gone ahead and drawn in where the 5 inches is in the window, and we need to figure out the perimeter. So we need to look at this piece right here, the middle of the square, which creates this little triangular piece on the edge. And if we can figure out how long one of these middles is, or another way to think of it is the hypotenuse of the right triangle we get when we cut the square in half, we can use that to figure out the perimeter. Note that the length of the diagonal of a square is the side length times the square root of 2. This comes from the Pythagorean theorem. Because we have a right triangle here, we would get this eventually. But the book goes ahead and just gives that to you. So we're going to just plug in 5 to figure out that piece on the edge. Next, we're going to consider the length and the width of the stained glass window design. So we need to figure out how many of these diagonals are on the length. So we have the first one in red. Here's another one, and here's a third one. So we have 3 of these 5 radical 2's. If we multiply that out, we get 3 times 5 radical 2, or 15 radical 2 for our length. We can use this same idea to check how many we have on our width, which is 2 diagonals. So there are 2 times 5 radical 2, which we can simplify as 10 radical 2. Reminder that the perimeter of a rectangle is 2 lengths plus 2 widths, because really you're just adding length plus width plus length plus width. Since our length is 15 radical 2, we can substitute that in, and since our width is 10 radical 2, we can substitute that in for W. Now we just need to simplify. So 2 times 15 radical 2 will give us 30 radical 2. 2 times 10 radical 2 will give us 20 radical 2. And notice we still have a square root, radicand of 2, radicand of 2. So we are allowed to combine these two with addition. So if we have 30 here and 20 here, that's a total of 50. So now we have 50 radical 2. If you plug 50 radical 2 into a calculator, you should get about 70.7. So the perimeter of the window is about 70.7 inches. Really quick, I just wanted to remind you guys where this S radical 2 came from. So we were looking at this right triangle that we got from cutting the square in half. So the diagonal of the square was S radical 2. That is something that you learned back in geometry or math 2. But it comes from the Pythagorean theorem, which you definitely went over in math 1 or 2. So here we have a square that was cut in half, so the sides are both 5, and then we have the hypotenuse c. The Pythagorean theorem tells you a squared plus b squared equals c squared, where a and b are both 5 in this case, so we can plug in 5. So 5 squared plus 5 squared would give you 25 plus 25, which is 50. Now we want c, not c squared, so you're going to square root both sides, which will give you just c, and then we have the square root of 50. Well, 50 is the same as 25 times 2, so square root of 25 times the square root of 2 equals c, but the square root of 25 is 5, so now we have 5 root 2 equals c, which is what we got from plugging in our side length of 5. So rather than making you do all of this work again, you were allowed to just steal that formula that you should have learned in math 2. The work for this problem is written out on the next few slides. They don't go over the Pythagorean theorem. They just say, using that formula, we know that the diagonal of a square is S radical 2. Now I would like you to try number 3. The design of a garden path uses stone pieces shaped as squares with side length of 15. Find the length of the path. So again, you can use that shortcut of the diagonal being S radical 2.